Hello friends, welcome to SURIYAS. If you are new to my channel, kindly subscribe to my channel. In today's video, we'll discuss about conics. Conics means it's nothing but a curve which is obtained by tracing a moving point. The curve which is obtained by tracing a moving point is nothing but a conics. So this conics can be classified based upon the conditions of this moving point. So based upon the conditions of the moving point, the conics can be classified as either a conic section or a involute or an cycloid. So for a conic section, the condition of the moving point will be the distance of this moving point bears a constant ratio from the fixed point and from a fixed straight line. So the distance of the moving point bears a constant ratio from the fixed point to a fixed straight line. That's the first condition of the moving point to obtain a conic section curve. So here we are having totally three terms. You are having a ratio. This ratio will be a constant, and that ratio will be calling it as eccentricity. It is denoted by E, and the fixed point we will be calling it as focus, and the fixed straight line will be calling it as directrix. So these three terms, based upon these three terms, we will be obtaining the first type of conic curve, that is nothing but conic section. So when this eccentricity, so for example, if you are considering this one as the fixed straight line, here mark it as AB. So this one is a fixed straight line, you are calling this one as directrix, and the fixed point, let us assume that fixed point F be here, and this one is nothing but the focus. Okay, so this one is nothing but the focus. So now we are considering a point. So this is the initial position of this point. So assume this point as P1. So the distance from the fixed point, you assume that this one is 2, and the distance from the fixed straight line, you assume, for example, this one is 4. So this is the initial point. So then what is the ratio? The ratio is nothing but the distance from the fixed point, which is nothing but 2 units, over distance from the fixed straight line is 4 units. Okay, so initially this point is P1 is here. For example, this point P is moving towards this direction like this. For example, if you are considering this point is P2 here, then if this distance, if you are assuming this distance is 2.5, and the distance from the fixed straight line, it will be 5. Okay, so the next point, if the point is moving from P2 to P3 here, this is the third position. So from this point, if the distance from this focus is 3, that is fixed point is 3, and from the fixed straight line it will be around 6. So what will be, this is the initial position P1, and for the second position, what is the distance? It is 2.5 over 5, and the third position is P3 is it's 3 over 6. So likewise, all these ratios will be it's a constant. Okay, so 2 by 4 is 1 by 2, and similarly 2.5 divided by 5 is 1 by 2. Once again, 3 by 6 is also 1 by 2. So it bears a constant ratio which is coming around as 0.5. So this ratio will be constant wherever the point is moving. So such kind of curves is known as ellipse. Such kind of curves is known as conic section. So when this ratio is less than 1, we will be calling it as ellipse. When this ratio is equal to 1, we will be calling it as parabola. When this ratio is greater than 1, we will be calling it as hyperbola. So that's the case for the first condition of the moving point, that is when the moving point bears a constant ratio from a fixed point to a fixed straight line, then it will form a conic section. So under conic section, we are having three types of curves, that is nothing but ellipse, parabola and hyperbola. For ellipse, the eccentricity ratio will be less than 1. For parabola, the eccentricity ratio will be equal to 1, and for hyperbola, the eccentricity ratio is greater than 1. So the second type of conics is nothing but involutes, in which the condition of this moving point will be assuming a point on a straight line, assuming any point P on a straight line, and this straight line will be of infinite length, and when this straight line is revolved over another surface, then the path traced by this point P. This is revolved over another surface, then this path traced by this point P is known as involute. If it is revolved over a square means then it is nothing but an involute of a square. Similarly, if it is revolved over a circle, so this is a circle. So here you are having this straight line. So fixed, you are having a straight line of infinite length, and if you are considering this point P over this straight line, and if you are revolving this line on the circumference of a circle, then the path traced by this point P is known as involute of a circle. Okay, so that's about the involute. So in case of involute, you'll be considering a straight point on a straight line of length, infinite length. When this straight line is revolved over another surface, then the point P, which is on the straight line, the path traced by this point P will forming a involute curve. Cycloids, in case of cycloids, you will be considering a point on the circumference of a circle. Okay, and this circle will be revolved over the circumference of another circle of greater radius. Okay, so when this circle revolves over the circumference of another circle, which is, this one is fixed one, so on this circle, then the path traced by this point P is nothing but cycloids. Okay, then this point P, the path traced by this point P is nothing but cycloids. If the rolling circle is rolled on above the circumference of this larger circle, above the circumference of the larger circle, it will form a epicycloid. And when the rolling circle is revolved, epicycloid, just to shortage of space, writing like this, so that's epicycloid. And in the rolling circle is revolved inside the larger circle. So this one is the rolling circle. You are considering this point P here. Like this, if you are revolving means, then this one is the center of this larger circle. Then the curve which is obtained by tracing this point P, which is on the rolling circle, which is rolled inside the circumference of a larger circle, then the type of cycloids which you are obtained here is nothing but hypocycloid. So cycloids is nothing but, cycloids is obtained by considering a point on a rolling circle when this rolling circle revolves over another circle. So in today's videos we have discussed about what do you mean by conics. So in case of conics, we are having three types of conics based upon the condition of the moving point. When the moving point bears a constant ratio between a fixed point and a fixed straight line, it is nothing but conic section. Under this conic section, we are having three types of curves. That's nothing but a ellipse, parabola, and hyperbola. And in next type is when the next type of conics is nothing but your involutes, in which we are having a point and a straight line. When this straight line is revolved over the surface of another surface, then the path traced by this point is nothing but involutes. Similarly, we are having cycloids. In case of cycloids, we are having a point on a circle, and when this circle is revolved over the surface of another circle, that is nothing but your cycloids. So in case of cycloids, we are having epicycloids. When the circle is rolled on the outer side of a circle, that is nothing but it will form a epicycloid. When the circle is revolved on the inner side of a circle, that is nothing but inner side of another circle, that is nothing but you will be getting hypocycloids. Okay, so that's all about today's video. In the next videos, we will be discussing about how to construct these curves. If you like this video, kindly share this video to your friends. Keep supporting Sai Surya's Academy. Thank you.